relaxation oscillator using operation amplifier. This is the circuit diagram for relaxation oscillator using operation amplifier. Now for a given frequency we have to design the circuit, and we have to calculate value of R1, R2, R and C. Now let us consider that the given frequency is 1 kilohertz, and therefore the time period will be equal to 1 millisecond. Now to calculate the value of R1, R2, R and C, we should know where a time period of a generated frequency, the time period of the generated frequency at the output. That equation should be known to us, and that is the time period of the waveform will be generated at the output of this relaxation oscillator. Then this time period is given by these equations, and where B is equal to R1 divided by R1 plus R2. Now in this equation, if we substitute R2 equal to 1.16 of R1, if we maintain that relationship between R1 and R2, then B will be equal to 0.463, and if we substitute that value to the equation number 1, we can see that this 1 plus B divided by 1 minus B will be approximately equal to the value of E, and the equation number 1 will be reduced to a very simplified form, that is T equal to 2 into RC. Now already I told the given frequency is 1 kilohertz and time period would be 1 millisecond, and because we have to maintain a relationship between R2 and R1 to reduce this equation number 1 to in the form of equation number 2, therefore we take R1 equal to 10 kilo ohm, and therefore R2 should be 1.16 times of R1, therefore it becomes to be 11.6 kilo ohm. Now let us take the capacitor. Here you can see there is a capacitor value, let us take 0.1 microfarad, and if we take 0.1 microfarad, the capacitance of the value of the capacitor, then from the equation number 2 you can see that we can find the value of R, that is equal to, you can see equation number 2, you can R is equal to T divided by 2 into C, and we substitute that value, it comes to be 5 kilo ohm. Therefore from these calculations we come to that R1 is equal to 10 kilo ohm, R2 is equal to 11.6 kilo ohm, R equal to 5 kilo ohm, and C is equal to 0.1 microfarad, and that has to be connected accordingly what shown in the circuit. Then we'll get an output waveform from the pin number 6 of the frequency of 1 kilohertz. For that we should go to the lab. Let us go to the lab. Demonstration of a relaxation oscillator using op-amp for a given frequency. Now let us suppose that given frequency is 1 kilohertz, and for that 1 kilohertz we, after designing the circuit, we got R1 equal to 10k, R2 equal to 11.6k, and R equal to 5k, and C equal to 0.1 microfarad, and this is the circuit here. And for relaxation oscillator with using op-amp, this is the circuit here. Now we are coming to the connections. You can look at the connections. First is the 7, the pin number 7, 1, 2, 3, 4, 5, 6, 7. 7 is connected to the plus VCC, that means here plus 12 volt. And 4, you can see the 4 is connected to the minus 12 volt. You can see the 4, 1, 2, 3, 4. 4 is connected to the minus 12 volt. It is written minus 12 volt. After that we are coming to the R1. How we connected the R1? R1 is equal to 10k. Therefore we have a 10k, and the color band is brown, black and orange. This is the 10k. You can see here the 10k 1, 2, 3, pin number 3, one end is connected to the pin number 3, other end is connected to the ground. One end of the resistance is connected to the pin number 3, other end of the resistance is connected to the ground. You can see this is the ground, is connected to the ground. Now coming to the R2. R2 is 11.6. 11.6K, we don't have 11.6 in the lab. Therefore, what we have done, the 10K we have taken plus 1K, it becomes 11, and then 5.6 ohm. Therefore, together approximately it is 11.6K. Therefore, you can see here, this is the 10K, this is the 10K, this is the 1K, and this is the 560 ohm. Therefore, these three together giving almost approximately given us 11.6. That is the starting point. Pin number 6 is the starting point, and other end of the 2 will go to the pin number 3. Therefore, this is the ending point. Other end is going to the 3. You can look at that. This wire is going to pin number 3. Next, you come to the R. R is after the we got it the designing. R equal to 5K. Therefore, R you can see. You cannot use the other pins because these are the pins 1, 2, 3, 4, 5, 6, 7, 8. You cannot use that. Therefore, it has to be connected. One end will be connected to the 6. Other end has to be connected to the 2. Therefore, what I did, this is the 5K. This is the 5K. One end is connected to the 6. Other end is I connected. These are all free terminals. Therefore, I connected to one terminal here, and from that terminal, I have taken an extension to 2. This is the extension to 2. Therefore, this is the again I repeat, this is the 5K. One end you can look at the one end is connected to the 6, other end is connected to the 2. Therefore, one end is connected to the 6, other end is I connected here, and from here I have taken a wire with an extension of the wire. I have connected to the 2. Then coming to the capacitor. Capacitor will be one end will be connected to the 2, other end will be connected to the ground. Therefore, capacitor one plate is connected to the 2, terminal 2, and the pin number 2, other end is connected to the, you can see capacitor other end is connected to the ground. That is all about the connections. Now coming to the what the waveforms we are getting on now. Now we switch on that power supply. After switching on the power supply, you switch on the oscilloscope. After switching on the oscilloscope, we have already adjusted the oscilloscope here. Then you can see, you enter the system here. You can see that you can see here that now I will show the waveforms in the oscilloscope. Now you can see the channel number 1, and I have to connect the output waveform. Therefore, this is the red one. I am going to connect to the output waveforms available in 6, and therefore red one is connected to the 6, and the black one is connected to the ground. Therefore, we have taken an extension here to connect to the ground, and therefore you can see that the output waveform is connected to the rectangular waveform, and then capacitor waveforms also will get it. The channel number 2, this is the channel number 2 here. This is the channel number 2. Again, the red one is to be connected to the capacitor, the plate which is connected to the 2, and that is the point where you should be careful here. You should not connect the channel number 2 red terminals to the ground plates, because ground plates will give the 0 voltage. You have to connect to the where the capacitor plate is connected to the pin number 2. That point only you should connect to the red one. After connecting it, and then the black one should be connected to the ground. It's a common ground. You should connect to the common ground. You can see then we are getting a capacitor waveform. Now we have to justify here that these waveforms we are getting here, the output waveforms we are getting here, it is of 1 kilohertz. Now you can see here in the oscilloscope, you can see here time division. Time division is a horizontal divisions, and it is showing here 500 microsecond. And we can adjust with this, adjust with this, and we can see that one cycle consists of one high and one low. Therefore, to complete two division it consists in one cycle. Therefore, one cycle is 2 division, and therefore 500 microsecond multiplied by 2, that means 1000 microsecond, and is the time period. That means time period is 1000 microsecond, and then your frequency will be 1000 microsecond is 1 millisecond, and therefore your frequency will be reciprocal of 1 millisecond is equal to 1 kilohertz. Therefore, whatever we have designed the circuit for, and therefore in the waveform also, output waveform is complying the same thing. It is producing a waveform of 1 kilohertz.